and still, after all these years, we still want it. And today, more than ever, we need all the efforts that are possible to mitigate climate change. But at the same time, we need still to provide universal energy access. As Ban Ki-moon said, energy is the golden thread that connects economic growth, social equality, and environmental sustainability. So how do we speed up climate mitigation and provide universal energy access? So we have first energy efficiency, use less energy to provide the same amount of services. Energy efficiency is the cheapest, as Mia said, the cheapest and cleanest kind of energy. Second, we have cleaner energy sources, such as renewable energy. But the third factor is innovation. And one definition of innovation is to combine external and internal elements to look for advancement. So in this case, innovation is provided by IoT or Internet of Things. So before going any further, I will provide, the main question here is how IoT can contribute to help us to achieve energy efficiency and renewable energy goals. So I used 3 use cases to demonstrate this. So IoT applied to industry, to PV plants, to manufacturing, to buildings, and across case analysis. And before going further, I will provide a definition of IoT because it's a very buzzword that many people think that IoT are smart refrigerators or smart appliances. And yeah, it is, but it's a very short view because IoT is about connecting. Interconnecting sensing and actuating devices, those are the things, providing the ability to share information across platforms, and developing a common operating picture for enabling applications. And this is achieved by communications, data analytics, and information representation. So we say, okay, it's important to have a visualization of the data. And we have, if you want, you have to remember something. Okay, you can remember this. We have the things that can be sensors, actuators, anything that are interconnected, and they don't need a human intervention to communicate. We have the network, in the coming years, 5G, but the networks are to communicate those devices. And most importantly, we have analytics. And analytics, maybe for use a new term, it's a way that the information is used. So data is meaningless if we don't use it. It's like taking a bunch of pictures, storing in your computer, and never seeing it again. So what we do with analytics is to use that information. And depending on the quality and quantity of the data, we can have different kinds of maturity of analytics, such as having a descriptive analytics to say what happened, so we have historical data, or to have like diagnostic analytics to see why does it happen, or more mature kind of analytics in order to predict what will be the next outcomes, or a more spooky kind of analytics. What should I do to change a behavior, to change a pattern? So it depends a lot in the kind of data that we have. So the first case is industry. And there's a lot of motivations to apply IoT in industry. First one, because it's important to the economy. Also because it's a big deal in terms of emissions. The third one, especially in Europe, because Europe and Germany lost their competitiveness in terms of manufacturing. So they are really working hard to be again one of the main players. However, they need to do this in a sustainable manner. For this, as John will mention in the morning, there is this initiative ruled by the federal government, but there are other similar initiatives called Industry 4.0. And the main purpose of this is to use the digitalization in order to be more competitive and to have an optimized value chain. So what are the things here? So we have this is a very simple layer view, communication layer view of IoT. So you have the device layer, network layer, service layer, and application layer. So in the device layer, we have in a manufacturing are, well, we can measure temperature, pressure, humidity, weight. We have actuators or remote devices such as pumps, valves, conveyors, motors. Also radio frequency identifications such as tags for products, containers, tools, so in order to look them and to see where are they faster. And also cyber physical systems that are more complex systems that has their own intelligence, such as assembly lines, robot arms, etc. So we have a network layer and a service layer. And these layers are more concerned with IT. And this can be reused, these layers can be reused depending on the manufacturing. But then I think one of the most important things is the kind of applications that we have. Because here, one of the objects of enhancing the manufacturing is to provide applications that optimize the processes in the whole supply chain. So, for example, track and tracing of objects, asset management, fleet management, virtual factory simulation, responsive manufacturing. So at the end of the day, as we can see, we don't have like a specific application to use renewable energy on energy efficiency. However, we have an holistic optimization that at the end of the day will decrease the CO2 emissions. Through analytics and the cyber physical systems, the Industry 4.0 or industrial internet initiatives can integrate different systems. So yesterday in the factory, in Siemens factory, we saw that we have different kind of departments, but none of them talk between them. So the information stays in one room. So the idea of having IoT applied to manufacturing is that the information goes horizontally instead of silos. So we can integrate different information of different departments and use them in our benefit. Because of this, we can have a more comprehensive understanding of the impact in the manufacturing and all the variables. And we can know and change the shift because we know how to do it. And for this, IoT fosters the use of demand response mechanisms that at the end of the day will help to make a better use. For PV, well, it raised a lot the installed capacity. Europe and Germany are market leaders in the installations. And according to IRENA, in order to reach a bigger market share in PV, we must double the capacity in the following years. So just like a reminder, what we want to have in a PV plant is to maximize yield, maximize marketing. Also yesterday, the guy who guided us in the PV farm told us, okay, we have 15 minutes to decide the price of the energy. And in this 15 minutes I can ask my frog, or my sand lizard, or my magic ball, because we don't know. But still, we have to do it. And also, we have to decrease operational cost, as you said, with monitoring and fault recovery. So what are the things in a PV plant? Of course, photovoltaic modules, inverter, data logger, digital power meter, environmental station. So we can have like an environmental station on site and provide a better weather view. There are several protocols here to communicate those devices. And one thing here is in the service layer, we have not only analytics, but also big data, because we can have the data not only every 10 minutes, we can have the data every second. But as you may understand, okay, having this data, it's also challenging because we need better, we need a larger hardware and software. So this is why big data help us to manage all this amount of information. And some of the applications that are available are performance estimation, optimization, predictive maintenance, and also dynamic alert and reporting, remote security, life cycle management, and prevention insight, and of course the prediction of the marketing. So we have more granularity in the data that helps to predict behavior from yield, so we can have better marketing. We can have also real-time data, so we don't have to go to the data logger every day and maybe see the behavior and base our decisions based on historical data. So we can use data that actually is happening. And in this sense, also the manufacturer or the utility company can monetize the data. And by this is that we know our equipment, we know standard situations. And I remember Hadi yesterday said, okay, it's very sad that PV farm or a German company are using Chinese modules because the solar, First Solar should be like the national pride, and now it's in insolvency because the cost. But if I'm in purchasing department and I have to make the decision, I will say, okay, both on paper seems the same because they are tested in standard conditions. But if I'm able to prove them side to side in my own conditions, that could be Germany, could be Mexico, or could be Jordania. So there are different conditions and they may behave in different ways. But with IoT, it's possible to have this long-term view and to compare one-to-one which is better. So at the end of the day, it could be like the German ones are really the winners, or maybe the Chinese, although they have not so much good quality, they behave just as okay. And buildings. Buildings, it's also a very interesting topic to me because I spend a lot of time working on smart buildings. And this is important because it accounts for 25% of the final consumption in Europe, at least. But 75% of the buildings in Europe are inefficient. And that shocked me because I thought that Europe was like doing well. I don't know what will be in Mexico. And by 2050, more than 70% of the population in Europe will live in cities. So do any effort in buildings, I think will pay for renewables and for energy efficiency and to decrease the CO2 emissions at the end. And as Maria Kreutzberger said, the more efficient the building, we have the more renewable energy sources for other purposes. So this Sankey diagram shows that for every 100 units of energy input, only 9.5 reach the energy output, to the final customer. So imagine, first, you have to be efficient in order not to waste so much energy, and second, have on-site renewable energy, make much more. So in buildings, what are the things? Well, we have, again, temperature, environmental monitor, that we can manage air quality. So for example, for hospitals or for places where people get sick very often, it's important. Also, light, it's one of the environmental things. Occupancy sensors, so for example, we are here in this room. Now it's late, we are tired, and we are more than maybe in the morning. So if we have sensors that can tell us, okay, how many people is in this room? What is the temperature? What should be the comfort temperature for them? So the system, the HVAC system, can adapt to our needs. So we don't feel like, oh, too tired because it's too hot and it's too late. So this can enhance the comfort and productivity of people. Also, they can help to track people. And as a cyber-physical systems, we have, of course, the heating, ventilation systems, lighting systems, security, smart elevators, fire. All these silos that we're working in a building can work together with an IoT overview. Buildings are, I think, one of the most mature markets, so they have plenty of protocols and applications today. They are using analytics in order to predict the user behavior, and so we can have better energy management, a predictive energy usage, control electrical loads, energy consumption, use energy vehicles charging, because if you are integrating renewables and whenever you have a surplus, you can use that in order to charge a vehicle. Fault recovering measurement and verification as well, because, again, the ESCOs are the most, I think, interested in just to see if they reach their efficiency goal, but sometimes it's very difficult to find out because you don't know if it's because your measures or because the user behavior. So with IoT, we have been deploying different sensors, it becomes much easier. So what are the benefits? IoT speed up deployment of energy management projects. Before, they were meant to be for larger projects because it costs millions of dollars sometimes. So to have a commercial or small project, with a couple of $1,000s, it's possible to do it. And we can have energy saving. Also, we have more data granularity and data coming from different databases, such as a weather channel. So we can correlate not only the data in our building or in our facility, but also the data coming from other sources. And it's also possible to find correlations. So we can have, again, these silos that I was talking about, heating water, heating a room, also the lighting, the number of people in the building. We can correlate this data, so we can predict and we can manage also, and we can have this prescriptive analytics to say, what should I do in order to decrease my energy output? So I did a cross-case analysis. I will mention some of the strengths, weaknesses, and opportunities and threats. So one of the main strengths of IoT is to collect real-time data. Also to have the capability of predict what will happen, and that is accessible not only to big projects, but also to small and medium enterprises. The weaknesses are that, well, IoT became energy consumption by itself, because you need more computer programs, maybe not running local, because there is a cloud and there is a data center running somewhere in the world. But again, since this will run massively, we will consume more energy. And also, there are multiple standards and regulations. As you see, there's a lot of protocols. Every day comes a new standard, so this is difficult to manage. But we have plenty of opportunities. We have a lot of policies. We can monetize this information, so not only used to reduce the energy or the power that we need, but also to enhance the products, not only to see how they behave, but also to enhance future generations. And raise awareness, because also we have a view of what we are using, and we get what we measure. So if we can able to see that maybe in a nice application or a dashboard, we will able to have an idea of how to become more. Also, the market is ready. Maybe the technology is not perfect, but now it's there, and it's becoming more and more affordable. And there are new and plenty of applications that we can use to decrease our energy usage. And the threats, well, the first one, and I think that is very common in any IoT project, is security, because we are generating data and we are using more internet-connected devices, so we know that hackers are there, and yeah, our information can be stolen. Also, other thing is the lack of interoperability between vendors. Although there are standards, sometimes they don't talk with them, and yeah, that's a problem. Also, customer may perceive that IoT is a costly investment, which is not, because there are plenty of open source programs, free programs that can be used for small implementations. But this is mainly because IT is not the core part of any project. So it's more a tool than a core part. So you say, okay, I don't need a new IT tool to bring. And most important, I think this is where it is not related to engineering, it's more related to internal processes, the resistance to adopt a new innovation. So IoT it's a revolution, a digital revolution, but we still need an internal transformation in all companies and in industries in order to adopt IoT. What are the opportunities? Well, first, optimize our processes by understanding what we have and how we communicate. We can enhance our businesses. Second, we can enable real-time monitoring and have predictive maintenance. We have a cost-effective and scalable project. It's not like, okay, energy management is only possible for large facilities. We have additional data integration, and we can identify patterns. So we may say, okay, every building is different in the world and have different users. Yes, but we can have like 1 million patterns, and you will fit in one. And also to have prescriptive analytics. So we can say, okay, what should you do to decrease your energy consumption? As a conclusion, I can say that, yeah, for sure, I think that IoT will innovate all the markets, not only energy, but each use case that I study present novel applications. By far, buildings is the most mature application right now. And I love that because I think that buildings is like a microcosmos of a smart city or any project, because we have different kind of usage. So I think that this experience will leverage not only to small and medium buildings, but to other use cases. In the case of manufacture, okay, it is not like the main goal, but the technology is there. There is this support by the federal government, and therefore I think that there is interest to achieve an holistic optimization. And for PV plants and renewable plants in general, there's still a long way to go, but I saw that there is a convergence between renewable technology and telecommunications stakeholders. And, okay, to answer the first question, yes, IoT can contribute. Why? Because it can optimize the processes. It will enable cost-effective real-time monitoring, predictive maintenance that at the end will reduce operational cost and enhance the lifetime value of our renewable systems. So that's all. Thank you.
Thank you very much, Alejandra. I will follow your example, Fadi. I will also ask the first question myself. Thanks a lot for a very interesting presentation again. You told me ahead of the presentation that in your thesis you wanted to look at many more case studies other than the 4 that you actually presented.
Yes.
And my question comes a bit from that statement you made. How do you think, not only on the plant control and general manufacturing industrial demand point of view, but how will Internet of Things change consumer behavior? Or in European, for instance, but also for instance, in developing countries where mobile phone penetration is already quite high compared to the energy situation. In 2040, how will it have an impact on our lives and impact on the lives of people in developing countries?
Right. Well, I think that IoT as Internet, it's something that it's achievable for everybody, not only for developed countries, but also for any emerging market. So today, here in Germany, in Mexico, in India, we all can access to Internet. And I think that IoT will be very important in the future because anyone with Internet access can learn how to program a device. I mean, it may have a learning curve, but you can do it. And most important, there are so many free tools to do that it's only a matter of imagination and a matter of will to do that. So I think that in this case, the economical barrier that we have won't be that important for IoT development. So my point of view is that as long as there is internet connection and open source tools, and open source tools can be software and hardware as well. So I think that any economy can develop IoT solutions.
Thank you.
Okay, I want to thank you for the informative presentation. I want to know your point of view regarding dealing with this massive amount of data and the complexity in the segregation of data, even the cost of handling too much information and the hardware, the human resources, the operation and maintenance cost. And the most important thing is, isn't this too much information might distract us from focusing on the important information?
Yes. Well, nowadays, all these IT advancements help us to manage that amount of information. We are generating today, well, in general, the information in one day, what we generate in 20 years. So the computer systems are getting prepared to handle this amount of information. And what is, I think, one of the prettiest things of technology today is that it's becoming more. So, for example, you can have Amazon services where you can store data. So you are not, you don't have to pay for maintenance cost or to have the server in your own place. You only pay the service, where you can store your data in the cloud with security, with privacy, and reliable qualities. But yes, this can be a problem because you can have a lot of data and you don't have like an IT specialized people who will analyze and will manage this kind of data. There are applications, of course, but if you maybe go to a technician that maybe he can handle a computer but not a database, could be a problem. But because of that, there are becoming more and more service companies that help you to manage your data and to give you the insights, to give you a dashboard, customized dashboard. So you don't have to worry about how to manage, how to maintain, or how to store the data. You only want to have a nice dashboard to see how your data is behaving, the predictions that you may have, and that's it. You don't have to worry about the other IT stuff. So there are new business models coming from the analytics and the big data that it's coming.
Actually, have you heard about spurious statistics? Sometimes you have too much information. You might think you make do relationships, wrong correlations. Sometimes you can link to the successful songs of Madonna to the drown incidents in California.
Right.
So you can find these relationships with too much data.
Right, you can learn.
My concern is that this might distract from focusing on the important data, maybe. I don't know.
Yes, but also you have different approach. So we have to take in mind that it's always important to see the problem from different point of views. So maybe you thought that the airplanes were not problem in your rooftop installation because they barely pass. But there is another consequence. Maybe the turbocene that they drop affects your system. So I think that at the end of the day, the more information that we have may become our output richer. So it's a matter of, okay, decide if that's important or not. At the end of the day, okay, you have to focus on the business and the business objective, but you have also additional data that can contribute and can make a value to you.
Okay. What is very more value is not the amount of data, is network and infrastructure security against hackers. Later the hacker will succeed to intervene with every device that is connected as an IoT, then this is the issue. You have to.
Yes.
The network security is becoming even more.
Yes, it's becoming more and more a challenge because one of the things of IoT is that the sensors are supposed to be cheaper. And to be cheaper, the processing capacity must remain very simple. But at the same time, you want to have like encryption, algorithms, or authentication, and more. They are costly in terms of processing and become the network slower. So right now, there are researching in terms of how to enhance the security mechanisms. However, it will be always a problem. I mean, we start with this fortress, maybe in the Middle Ages, and now we have, I don't know, more secure buildings to protect us from threats. And that will happen the same with IoT. So we build security mechanisms, but it will be always a fight with hackers and non-very ethical people.
One last question.
Yeah, I think the biggest hurdle is going to be the perception of infringing on the personal privacy. This is specifically at the consumer level. It's basically, theoretically, this technology, and I've been reading about it, that it knows everything you can do. When did you last open your fridge? Why did you sleep late? Because you turned off the lights.
Right.
Why you're washing your clothes so many times a week, per week, and so on. The heater gives an indication to the everything basically you do is logged, and that's really a big infringement to the privacy of how we live and how we, and that's really going to be challenged.
Yes, that's why I say that the prescriptive part of analytics is spooky, because as you said, okay, I open my fridge like 10 times a day. So they may say, okay, you are hungry, and if you are hungry, I can send you a message of Amazon Fresh, like, yeah, for €1 I can send you food. Or if I load my washing machine, say, okay, I can offer you a new one, a better one. So yeah, there is a challenge about privacy, personal privacy, and moreover, into not falling in a profile. So you can be, okay, profile A, and I can send you this kind of information, because it can also end in manipulate people. And I think that's something dangerous. But I think that this is not related with technology. This is more related with humans.
Thank you very much.
Thank you.